Hello everyone. Today we will be solving question number 5 of February March 2025, variant 42. The question says manganese is an element with atomic number 25 in the periodic table. Calcium is the element with atomic number 20. Calcium with 20, manganese with 25. Complete table 5.1 to show the number of protons, neutrons, electrons in Mn atom and calcium ion. Because it has a charge here, I am calling it an ion because ions are charged particles. Now, the table is asking for number of protons, neutrons and electrons. Dear children, please note that atomic number is always equal to the number of protons in any atom. So atomic number is given here. For manganese, it's 25. So I'm going to write 25 here. For calcium, it's 20. So I'm going to write 20 here. Because atomic number is equal to number of protons. Now, how to find number of neutrons? So number of neutrons is always equal to atomic number minus the mass number. Now, atomic numbers are with us. For manganese, it's 25, calcium, it's 20, and mass numbers are also with us. Mass numbers, please note they are written here. The numbers written on the top left are the mass numbers. So, number of neutrons for manganese would be 55 minus 25, and that is equal to 30. For calcium ion, 42 minus what was the atomic number? 20. So this is going to give us 22. For number of electrons. Now let's be very careful for the number of electrons because in a neutral atom like manganese, the number of electrons is equal to the number of protons. I repeat, in a neutral atom means an atom with no charge, the number of neutrons is always equal to, number of electrons is always equal to the number of protons, which is the atomic number. So for manganese, the number of electrons would be equal to number of protons, that's 25. But for calcium, it is having a 2 plus charge. So you have to subtract this 2 from the number of protons. So it's going to be 20 minus 2. Yes, we are going to subtract. The plus 2 charge is representing that the ion has 2 more protons, or you can say 2 less electrons. That is why we are subtracting it from 20. For the next part, manganese forms several oxides. Yes, manganese, the symbol of manganese is Mn, and we can see different oxides being formed here. The formula of some of the oxides is shown. Suggest why manganese is expected to form colored oxides. Now, this is super simple. You know what? Manganese is a transition element. If you see the periodic table, this part of the periodic table is representing the transition elements. This part. Now, the transition elements have this ability to form colored compounds, and we are taught this. So, we can simply say that manganese is expected to form colored oxides because it is a transition element. So, for 1 mark, we can say just this much. The second part of the question says, state which other property of manganese is shown by the formation of several oxides. They want us to focus on the formation of several oxides and tell them which specific property of manganese is depicted by this. So, dear children, you should know that transition elements are able to form multiple oxides because of their ability to show variable oxidation states. So, the other property they are talking about is that manganese can show variable or multiple oxidation states. Now, just to make you clear that what are oxidation states, you must have seen written like Mn2 plus, Mn4 plus, or Mn7 plus. These charges that we write here are called oxidation states. In the next part, they're asking what is the formula of manganese oxide? Now, dear children, to form the formula, manganese is Mn and oxygen is O. We all know that oxygen belongs to group 6 of the periodic table. You can check it here. Oxygen is here, it's a member of group 6, and hence it has a valency of 2. Manganese, see in this bracket written here, the Roman numeral that represents its oxidation number or valency. So 2 will come here. Now, before doing the crisscross and forming the formula, you're supposed to simplify this ratio. So this is 1:1. They get cancelled and the ratio is 1:1. So the formula of manganese oxide comes out to be MnO. Always remember that whenever they give us the name of a transition element compound, a compound of transition element like manganese, they always mention the oxidation state in brackets because transition elements can show multiple oxidation states. So they have to specify this. The next part of the question is Mn3O4 is found in an ore of manganese. Ore is what? Ore is a rock that is obtained from the earth crust and it gives us minerals. Manganese metal can be extracted from this ore using aluminium as a reducing agent. Now they are saying that you can extract manganese from manganese oxide using aluminium as the reducing agent. And in the part of the question they are asking, define the term reducing agent. Now this is interesting and very simple. What is a reducing agent? A reducing agent is a substance that reduces others. A reducing agent is a substance that reduces other substances. Now, because this question is of 2 marks, we need to add one more point, and we'll say that and is itself oxidized, that it oxidizes itself. Yes, so 2 marks, 2 points. Part number 2, complete the symbol equation by inserting the formula of the missing product and balancing the equation. Okay. So we have to complete the reaction by writing this product and then balance it. Now, this is going to be very simple. Just have a look that what is missing on the right hand side. Now, on the left hand side, we have manganese, oxygen, and aluminium. I'm not counting the atoms right now. I'm not balancing it. I'm just figuring out what is missing on the right side. So, manganese is there on the right side, but aluminium and oxygen are missing. So, what is the formula of compound of aluminium and oxygen? So aluminium has a valency of 3 since it belongs to group 3 of periodic table. Taking you to the periodic table, aluminium is here in group 3, so the valency is 3. Oxygen we just discussed here also. It's a member of group 6 and hence has a valency of 2. We cannot simplify 3:2 further. So we'll just do the crisscross thing and the formula becomes Al2O3. Now to balance it, we see we have 2 aluminium atoms here, so I'm just putting a 2 here. Then we have how many manganese? There are 3 manganese here, but 4 oxygens. Okay, so to balance these 4 oxygens, we need to, here it is 3. Here it's 4, here it's 3. So let's multiply this by 3 and have a 4 here. Because having a 3 here will make oxygen 12 because 3 times 4 is 12 And having a 4 here will make 4 times 3, that's 12. So number of oxygen is balanced here. We need to change this number 2 we wrote in front of aluminium, because now we have 4 times 2, that's 8 aluminium. Please remember that we have to multiply this coefficient with this subscript always. So, and now for manganese, 3 times 3 is 9, so it's a 9 here. And it seems balanced. Yes, it is. So we will get 1 mark for balancing and 1 mark for writing this product. Always remember, for writing the product, you need to just figure out that what is missing on the right hand side. For the D part of this question, manganese oxide reacts with dilute HCl as shown in the equation. Calculate the volume of chlorine gas formed at RTP when excess of MnO2 reacts with this much volume and this much concentration of HCl. Please note whatever is given. We have been given that MnO2 is in excess, so it's not the limiting reactant. It means HCl is the limiting reactant. The volume and concentration of HCl is given. The first part is very simple because they are asking us to calculate the number of moles of HCl. So, dear children, we should know that concentration is equal to number of moles divided by volume, which implies that number of moles is equal to concentration times volume. So concentration is 0.200 and volume is 50 cm cube. Now a point to be noted here is that the volume is in cm cube and the concentration is in mole per dm cube. So dear children, for converting cm cube to dm cube, we are supposed to divide by 1000. So we'll divide this 50 by 1000. And what we will get is 0.01 moles. Yes. So this simple. Now they're asking determine the number of moles of chlorine formed. Okay, so in this case, we'll simply be taking the molar ratio of HCl and Cl2. So HCl and Cl2. In this case, whenever they ask us to find the number of moles of one substance with respect to the other, we always take help of balanced equation. This coefficient here represents the number of moles. So as I see from the balanced equation, 4 moles of HCl produce 1 mole of Cl2. So I'm going to figure out that if I have 0.01 moles of HCl with me, how many moles of Cl2 will be produced. Now in that case, it's super simple. We just need to put these ratios equal. That okay, 4 ratio 1 is equal to 0.01 ratio x. So 4 upon 1 is 0.01 upon x. Now solving this mathematically will give us x is equal to, which is equal to 0.0025. 0.0025. So our answer is 0.0025. That's how we figure out for this part. Now they're asking calculate the volume of Cl2 formed. In the previous part, they asked us the moles of Cl2. Now they're asking the volume. Dear children, we have a formula where we can convert number of moles to volume. And this is the formula. So we are supposed to find this V and number of moles we just calculated here. So 0.025 times 24 will give us volume and that will be in dm cube. But they're asking it in cm cube. So we will be multiplying this further by 1000 to convert it to cm cube. And this is going to be 60 cm cube. Yes, it's going to be 60 cm cube. Describe a test for chlorine gas. This is very interesting. Chlorine is actually a bleaching agent. It has bleaching tendency, which means that it just turns everything light in color. It makes the color go really light. So the test is a damp litmus paper test. You're going to bring a wet litmus paper close to the test tube releasing the chlorine gas. So this is the test tube which is releasing chlorine fumes. You're going to bring a damp litmus paper close to it. Whatever color you can take, blue or red litmus paper, observation will be the paper will go white, which means that it has been bleached. The color is bleached, it's gone away. That's the test for chlorine gas. For the next part, explain in terms of collision theory why decreasing the temperature decrease the rate. Now, dear children, this is very important. Decreasing the temperature, why decreases the rate? Rate depends on two things. Number one, frequency of collision, like how many collisions are happening per second. And secondly, it depends on number of successful collisions. So this is the thing. So when you decrease the temperature, what happens to the kinetic energy of particles? When you decrease the temperature, the kinetic energy of particles decreases, and hence the frequency of collision also decreases. Frequency of collision decrease, and what about the tendency of successful collisions? The tendency of successful collisions will also decrease because of that. So let me bring the answer exactly from the marking scheme for us here. Let's see. It says that the kinetic energy of the particles decrease, and hence the frequency of collision between the particles also decreases, and hence the percentage of collision decreases. Fewer the collisions, more particles have energy greater than or equal to activation energy. Sorry, less particles will have energy greater than or equal to activation energy. So basically, we are supposed to say in this answer that these two things are going to decrease. That's it. So I hope you have understood this question number 5. Thank you so much.